Hello, students. Today we are going to start chapter 13, Time and Motion. In this chapter, we are going to learn about slow or fast motion, speed, measurement of time, how to measure speed, different types of distance and time graph. Suppose you are standing near the open window of your room. You observe the vehicles, cars, buses, cycles, etc. All are moving. No one seems to be at rest. All are in motion. So, what do you understand by the term motion? The object which changes their position with respect to the object at rest are called in the state of motion. These objects are called that they are in the state of motion. If they changes their position with respect to certain objects which are at rest. If an object covers a larger distance in a fixed interval of time than some other object, we say that that object is faster and the other object is slower. So objects may travel fast or slow. If an object covers larger distance in fixed interval of time than some other objects, then we say that the object is faster and the other object is slower. Next, measurement of time. Before going to the measurement of time, we will study what is time. Time is the interval between two events is known as time. The interval between two events is known as time. Then how can we measure time? Certainly you give an answer that we measure the time with the watch. But in olden days, in ancient days, when there was no time measuring devices such as clock, so how do people measure the time? They relied on the natural phenomena to keep track of the time. That is day, night, month, year. So how do they measure day? The time interval between one sunrise to the next was considered as a day. Night. The time interval between one sunset to the next immediate sunrise was considered as night. Month. The time interval between one new moon and the next was considered as a month. Year. The time taken by the earth to complete one revolution around the sun was considered as year. Next, evolution of clock. Sundial. A sundial is a circular plate with a triangular metallic plate called gnomon fixed at the center, pointed at an angle. The device is placed in the open sunlight in such a way that gnomon points towards north and south direction. But the major drawback of using the sundial is that the devices cannot be used during the night and cloudy days. So this is sundial. A circular metallic plate with a triangular plate which is fixed at center. This is called as gnomon. And this is always points towards the north and south direction. So this is sundial. This was the first invention in the clocks to measure the time. The major drawback of this sundial is it is always used in the daytime. During the night and cloudy days, it does not tells the time. So this was the major drawback. And this is sand clock. You may know about the sand clock. So second invention was sand clock. Sand clock is known as hourglasses. It measures the passage of few minutes or an hour of time. It has two vertical glass bulbs allowing a regulated sand from top to bottom. Once the top bulb is emptied, it can be inverted to begin the time again. So sand clock measures only few minutes or 1 hour or 2 hour time. So it has two glass bulbs. See, you can see two glass bulb and it contains the sand. The top bulb if the top bulb get emptied, then it can be inverted. In this way, we can measure the time through the sand clock. Next invention in the clock is pendulum clock. A pendulum clock is based on pendulum. So what is pendulum? Pendulum is nothing but a metallic bob is tied with the string and it is placed on a rigid stand. This is pendulum. A simple pendulum has a metallic bob suspended from a rigid stand by a thread. The rest position of the bob is called as the mean position or equilibrium position. When the bob of the pendulum is displaced, the bob of the pendulum undergoes to and fro motion. The pendulum is to set to have completed one oscillation when the bob moves from one extreme position to the other and back. So this is metallic bob. It is the mean position or the equilibrium position. This metallic bob moves. These are the two extreme positions. So it is taken to the one extreme position and you leave that metallic bob. It goes to the other extreme position and again back to the first position. So we say that one oscillation is completed from one extreme position to the other and then again back to that. Then we say that one oscillation is completed. Next, time period. The time taken by a pendulum to complete one oscillation is called as time period. The time period of simple pendulum varies with the length of the thread but does not varies with the mass. So time period always depends upon the length of the thread but not on the mass of the bob or the distance of the bob from the mean position. So it always depends upon the length of the thread but not on the mass of the bob. Next, periodic motion. The oscillation of simple pendulum are periodic, that is, they repeat themselves after fixed intervals. Such motion is called as periodic motion. The oscillation of a simple pendulum are periodic, that is, they repeat themselves after fixed intervals. Such motion is called as periodic motion. Quartz clock. With the invention of the quartz crystal in 1921, clock were discovered in 1927. So timekeeping accuracy was highly improved in this. They are replaced the pendulum clocks. The next is atomic clock. Atomic clock gives the accurate time, most accurate time. So atomic clock is a device that is used in uses an electronic transition frequency in the ultraviolet region. So we have different regions: ultraviolet region, infrared region, light visible region. So this atomic clock, they uses the electronic transition frequency in ultraviolet region of electromagnetic spectrum. Okay, the spectrum consists of different regions: ultraviolet, infrared rays, and visible region. So atomic clocks are the most accurate timekeeping devices. Speed. The distance covered by a body in unit time is called as speed. The distance covered by a body in unit time is called as speed. Speed is denoted by kilometers per hour, but the SI unit of speed is meters per second. In each and every vehicle, we have speedometer and odometer. Speedometer measures the speed of the vehicle and odometer measures the distance of the vehicle. Next, average speed. Average speed is defined as the total distance traveled in total time. So average speed is total distance traveled by total time. In this way you can calculate the average speed. This is the formula for the average speed, total distance traveled by total time. Next, what is uniform and non-uniform speeds? Suppose an object covers equal distance in equal interval of time, then we say that the body is moving in a uniform speed. For example, if an object covers 10 kilometers in 10 10 minutes, 10 kilometers in next 10 minutes, 10 kilometers in next 10 minutes, then we say that the object is moving in a uniform speed. But if a object is covering unequal distance in equal intervals of time, unequal distance means first in 10 minutes it has covered 10 kilometers, in next 10 minutes it has covered only 5 kilometers, in the next 10 minutes it has covered only 3 kilometers, then we say that that kind of speed is non-uniform speed. If an object covers unequal distance in equal intervals of time or equal distance in unequal intervals of time, then we say that the object is moving in non-uniform speed or varying speed. Similarly, we have non-uniform motion and uniform motion. If a body is said to have a uniform motion when it travels equal distance in equal interval of time, same in the same way. If an object travels equal distance in equal interval of time, we called it as uniform motion. If an object travels unequal distance in equal intervals of time or equal distance in unequal interval of time, then we say that the body is in non-uniform motion. Next, distance time graph. Suppose if an object is stationary with respect to time, if the object is at a rest position and time is changing, so we can draw a graph between distance and time, distance taken on y-axis and time taken on x-axis. Now an object is at rest but time is increasing, okay, then we get a straight line. The time increases to the right but the distance does not change, the distance is not changing, so distance is constant but the time is increasing. So the graph is this is the graph for stationary objects. Suppose if your car is not moving, it is at a rest position, then if you draw the distance time graph of your car, then you will get a straight line because the distance is zero, the distance it's not traveling but the object is but the time is moving, so it is a horizontal line. Next, if the object is moving at a steady speed, that means if an object covers equal distance in equal intervals of time. For example, if in 5 minutes it has covered 2 kilometers, in 10 minutes after 5 minutes, again 5 minutes, it has covered 2 kilometers, 2 kilometers after each 5 minutes, then you will get a straight line. This is for the uniform motion. You will get a straight line. If we plot a graph between the distance and time, then for the uniform motion you will get a straight line. So time increases to the right and the distance is steadily increasing with the time. So distance time graph for uniform motion always gives a straight line. Next, if the object is moving with the varying speed, that is, this graph is for the non-uniform motion, means it covers unequal distance in equal interval of time, then time is increasing to the right and distance is not increasing steadily, it is unsteady. So the distance time graph for the non-uniform motion will be curve, any curve like this or any curve. Okay, so this is the distance time graph for the non-uniform motion, this is the distance time graph for the uniform motion, and this is the distance time graph when the object is stationary. So these are the three graphs which are present in your syllabus. So till here your chapter has been completed. Thank you.